Hello, nice meeting you all. I'm Tim. I work as a performance consultant at Akamai. And in my day-to-day job, I use a lot of RUM or real user monitoring. And I really love RUM because it gives me insights into the actual conditions websites are seen or navigated. Good connections, bad connections, modern browsers, old browsers, high-end devices, low-power devices. It gives me everything. And when I tune real user monitoring, I like to look at the P99, like many of you. Of course, this is not the only thing I love in my life. I also have two kids, 8 years and 10 years old. Now, my kids and RUM and my kids and the P99 actually have one thing in common. They are very, very noisy. And during the pandemic, the solution for my kids' noise was quite easy. I bought some noise cancelling headphones. When it comes to the noisiness of real user monitoring data, that's all what this talk is about. Noise cancelling RUM, or how to get rid of the noise and make your P99 meaningful again. When you implement the techniques I will share, you will see that it's easier to spot new bottlenecks, that whenever you make a change that you will actually see something happening, and you're not wasting hours and hours and hours chasing the wrong things. This is a graph we all love to see. We find an issue, we make a deploy, and then the performance numbers improve. And this, when I see a graph like this makes me happy. However, this is not always the case. Sometimes we see graphs which are more like this. That's or even a flat line. And this is certainly true when you look at the P99. And the reason for this gap between what you expect or what you hope and the reality in RUM is likely noise. We will look at 3 different sources of noise. And if you add up all the noise, you arrive at 78% signal, or 78% of human visible navigations. That's what we will focus on. Human visible navigations, and by default, all the rest can be seen as noise and should be removed during your analysis. Now, I will use some data of my own website. So I run the largest scale modeling website in the world. It has about 50,000 visitors a day. And it's not only the largest scale modeling website in the world, it's also the fastest scale modeling website in the world. And if you don't know what scale modeling is, you buy a kit with some plastic sprues, you cut them off, you glue them, you paint them, you airbrush them, you weather them, and then you get a nice result like this. And whenever I analyze my website, I filter out 3 sources of noise. And the first noise source is navigations. If you go to the browser console and you type in this snippet, you will get the navigation type. And the navigation type can be captured as a dimension in RUM. And if you do that, and you look at my website, you will see that 15% of the navigation types are not regular navigations, people clicking on a link, but many of them can hit the back button, which is a back forward navigation, or you can hit the reload button. And my view is, by default, only look at navigations because the 2 others are noise. And on the next slide, you will instantly see why. Here you see the waiting time. So this is your time to first byte without DNS, TCP, SSL overhead, redirects, just the plain GET request, server think time, and then getting your first bytes back. What do you see? That the back forward navigations are a lot faster than the actual navigations. And because there's so many of them, this starts skewing your results. That's the first thing. So the actual performance is more around 96 milliseconds, while these ultra fast back forward navigations make, in this case, the P75, make that an 83 milliseconds. That's the first problem. So it looks better than it actually is. The second problem is many optimizations. For example, if you add an index to your database, or if you add some caching at the CDN level, what is the impact if for these changes for the back forward navigation? 0. You don't make those navigations faster. Therefore, you make a change which you think impacts the performance, while a huge portion of your population is not impacted at all. This is not the only problem. This problem actually heavily depends on the page you're looking at. Homepage, search, or a product detail page. And I have two types. You have the main scale modeling kit, and then potentially a lot of aftermarket or accessories like figurines, additional markings, etc. Now, what do you see here? The noise of the lightning fast back forward navigations resulted in a blind spot for my search. So 22% of my search beacons were lightning fast, resulting in the search page looking a lot faster than it actually was. Why? Not because my search was faster, just because there were more back buttons. So that was the first problem. The second problem, I noted in RUM that the aftermarket pages were slower than kits. And there was no reason for it except for some queries. So I spent hours and hours and hours wasting time tuning database queries because I thought I had an issue with my database, while the only reason the aftermarket sets were slower is because they had fewer fast back-forward navigations. And here you can see a nice impact on the total numbers is the back-forward navigations across all percentiles typically are faster, and they can skew your data. Now you might say, Tim, my site is different. I don't have a scale modeling website. And I fully agree. Luckily, the RUM archive, which was introduced last year, which is open source, gives you insights, aggregated insights into real user monitoring data, of course, in an anonymous way. And if you query that RUM archive with using BigQuery, you will, for example, see that across the board, not only my website has a lot of back-forward navigations, your website likely as well. If you then look at the performance impact, here you see a nice histogram, and the orange part, back-forward navigations, they are lightning fast, not only on my website, but likely also on yours. And as you can see on the left-hand side, you see that the bulk of the back-forward navigations are almost instant, therefore making your P50 look better than it actually is, therefore making your P99 look better than it is. That was the first source of navigation. Another big source, especially for the P99, is visible. I like to look only at visible navigations. And what do I mean with that? Is if you type into browser document.visibility state, you get visible when the tab is actually visible. Now, if you capture this in RUM, you can get 3 combinations. Typically, a page is always visible. From the moment the person started navigating, clicked on a link, till the beacon or till the full page load was done, the browser always had your tab visible. Now, in 7% of the cases, this is not true. And why does this matter? Let's have a look. Here you see that as soon as the browser shows the content in either a partially or always hidden way, that the performance drastically degrades. Why could that be? Well, it's easy. A browser prioritizes its work for what is actually visible, and tabs which are in the background or loading in the background get less CPU, less RAM, less priorities than the current active browser, which makes absolutely sense. Now, the thing is, in my case, 7% of my navigations are not always visible, where the browser says, I don't care about the performance. And the impact, here you see the impact on the P75 on the largest contentful paint. So this is when the actual image or hero font is visible, is quite impactful. Now, how many of you have tuned in the past the always hidden or partially hidden performance? How many of you, when you talk about performance, think about loading your page in a hidden tab? Nobody of us. We don't care about that piece of performance. Yet, in all our analysis, by default, we include those very slow things. And what is the problem? Again, it drastically impacts. But it's drastically impacted by the page you're looking at. For example, on my homepage, almost 11% of the views are partially or fully hidden. Meaning, if I look at the 95th percentile, 99th percentile, and I try to tune it, I'm tuning pages which are not loaded in an optimized way. Do I care about those page views? No. Again, search. Again, a blind spot. Compared to other pages, the search page actually looks quite fast. Why? It has relatively fewer very slow measurements. Only 1.5% instead of 10%. How, again, here I wasted hours and hours and hours because the aftermarket sets looked slower than the real kits, and I couldn't find a reason, and I wasted time tuning this. Again, if you look at the RUM archive data, we see a 10-ish% of very slow loading page views, which in the end nobody cares, but which really can influence your higher percentiles. Last, human. We mainly tune for humans. We don't care about bots. Well, we care about one particular bot, which is Google. Here you see the search console, and of course you try to improve the average response time. That's one thing. But there are many other bots which you don't like. On my website, for example, I share pricing information, and some people try to scrape that data. I also have a huge product database with barcodes and all other interesting info which some other websites might be interested in and try to crawl. Now, that's one problem, that's one thing. Now, why is this actually a problem when it comes to RUM analysis? Again, they add noise. And here is one particular example where I had to roll back due to bot activity. You see that spike on the screen around September 27th? Well, the day before, September 26th, I made some changes during the weekend, trying to optimize the performance of my website. And the next day, I hoped to see an improvement, and it was actually the inverse. I couldn't understand why, but as I like my end user experience, I rolled back. Only a few days later, I figured out that this was actually due to a bot hitting the website. This was particularly a German bot who every 3 to 4 weeks crawled during a few hours sent a huge amount of requests and also fired RUM beacons. Now, what was the problem here? This bot used an old dated Chrome browser, which still had some CLS issues, therefore skewing my data. So when it comes to bots, always cancel out the noise, because they are unpredictable. You don't know when they arrive, how many requests they do, or they might also, in this case, skew the population of old versus new browsers. So that's the thing. My tip for you is, when you want to make your P99 meaningful again, focus on human visible navigations, because if you don't, then you're likely looking at something you don't care about anyway. Before we close, you might say, why do RUM tools even bother tracking this data? Well, I actually love the noise for a bit of other reasons, because sometimes the noise becomes signal. For example, back-forward navigations, yes, it does not matter when you're tuning your waiting time. Yes, it does not matter when you want to understand how fast if your database update index was actually improving the performance. But back-forward navigations, you actually like them. For example, layout shifts, when you hit the back button, they can also occur. They can also impact your user experience. So you do, depending on the KPI you look, the noise is actually not noise, but can become signal. For bots, in general, it's always noise, unless you're talking to the security team. And then the 6% signal of always hidden and partially hidden, when the actual performance numbers, I don't care about them, but I do care about the percentage of noise. Because if that percentage increases, it could indicate that people no longer perceive your website as fast. Because if your website is fast, you just click around. As soon as it's slow, what do? Right click, open a new tab, right click, open a new tab. And you do that a few times, and then that signal, that noise becomes signal again. So my advice, if you care about RUM data and if you care about the P99, make sure to focus on human visible navigations, and this will make your life a lot easier. Spotting bottlenecks or not wasting time chasing the wrong things. Thank you very much for your time. You can always follow me on social, either X or on Mastodon or LinkedIn, or you can also reach out to me via email. Thank you very much for listening.